Thank you for joining me today. This is the track titled Mobile GIS for Operators, accessing your asset information anywhere, anytime, from any device. My name is Rusty Merritt. I'm the GIS Department Manager at Anderson Perry. I've been in the GIS industry for about 25 years, and I've watched it change dramatically. Now is a fantastic time to be thinking about GIS if you're not already using it. My goal at Anderson Perry when I joined them in 2016 was to make GIS practical, accessible, and affordable for the public works staff at small to mid-sized municipalities. Now I suspect that many of you have seen your areas of specialty evolve over the years. And needless to say, I've seen this happen with GIS as well. In particular, with the advent of smart devices, smartphones, tablets, iPhones, and cloud services, or in this case, the maps and the apps that make your data accessible and actionable. As a result, GIS is now readily available to organizations of any size and multiple users simultaneously who are connected through an internet-connected device. Now, in the 25 years that I've been doing GIS, I want to share that this is my first virtual presentation. That said, I'm going to do my best today to discuss the application of GIS for asset management, introduce you to what's called the ArcGIS platform, and finally, show you several examples of how our clients are using GIS to augment water and wastewater operations. My hope for today are really two things. One, that you realize that GIS is more than just a map. GIS is actionable information. GIS is accessible information. GIS is authoritative information for your organization. The second thing is that you glean one big idea about how GIS might streamline operations for you and your staff, whether it be water or wastewater. With that, thank you for joining. Let's get started. Now, if you've attended one of my presentations before, you'll know that I almost always lead with the EPA's Asset Management, a Best Practices Guide, and the 5 core questions of the Asset Management Framework. The target audience for this guide is owners, managers, and operators of water systems, and I'd argue wastewater systems, local officials, technical assistance providers, and state personnel. In other words, it's a guide for people like you and me. The guide defines asset management in this way. Asset management is maintaining a desired level of service for what you want your assets to provide at the lowest life cycle cost. Lowest life cycle cost refers to the best appropriate cost rehabilitating, repairing, or replacing an asset. Now, while I'm not here to speak about asset management plans per se, this guide does give us a framework, and a simple framework for asset management in general. And when we consider the 5 core questions as a foundation for a series of best practices, we see that the first step in managing your assets is knowing the current state of your assets. Specifically, what do I own? Where is it? What's its condition? What's its useful life? And what is its value? We can see that the guide goes on to offer a series of best practices, and in this particular case, the first item that I have highlighted in the list is preparing an asset inventory and system map. Now, traditional approaches to asset management involve what we might refer to as disparate information. In answering the question of what do I own, where is it, what's its condition, what's its useful life, it can be difficult because that information is stored across the organization in a variety of different formats. Examples might include spreadsheets, which could store our hydrant database, our manhole database, You may have inspection reports, more often than not in paper form, pad and paper maps, field notes, photographs. And while it's likely that your department has probably developed its own workflows around this type of information for collecting, updating, and storing your asset information, I think we can all agree that it can sometimes be difficult to find, use, and share that information across the organization, whether in the field or in the office. GIS helps us break these barriers down. And this slide introduces us to the concept of GIS as a system of engagement, which, simply put, is a system that empowers every employee to easily discover, use, make, and share maps from any device, anywhere, at any time. By using a web-based GIS, we can capture and store the location of our assets, the characteristics of our assets, the things that are typically within these spreadsheets, within these various inspection reports, in the cloud, and share this information in near real time with our coworkers. GIS also provides the added benefit of being able to integrate your information with other high-value data that we can obtain from third-party sources. Examples might include tax lot information from our local county providers. Those tax lots may have associated with them address and ownership information. And information can be easily retrieved through GIS. Perhaps we want to visualize our information, see our assets overlaid with a high-resolution aerial image. That's something we can obtain from the state of Oregon. Road layers, soils maps, etc. At the federal level, we may have FEMA floodplain data, water bodies, waterways, public land survey system, township, range, and section. These organizations are making massive investments in GIS information, content, what we call it, and you have the ability to incorporate that information into your maps so it's readily available to you in the field. In a general sense, the term GIS describes any information system that integrates, stores, edits, analyzes, shares, and displays geographic information for informing decision making. In this way, we have the ability to better organize our information, meaning we establish a single authoritative system of record. We can aggregate that information. That helps us decrease the time it takes to find and use information. Efficiency. It allows us to collaborate, to collect, to use, and update that asset information. A person in the field may update the location of an asset, the characteristics of an asset. And that information in near real time is available to everyone else in the organization, so we can improve collaboration. Finally, we can refer to another benefit of retention, which means we can protect from information loss. We know that many of you have probably been with your organizations for many, many years and know assets from just having serviced those assets over time. We also know that there are people that are new to the organization that know little or nothing about your assets. By using a GIS, storing the information in a centralized location, different people can use that information to support their work and jobs in different ways. I mentioned earlier I would talk about the ArcGIS platform. The ArcGIS platform is used by Esri to refer to a suite of GIS software products which operate on desktop, server, and mobile platforms. The ArcGIS platform connects maps, apps, data, and people in ways that help organizations make informed and faster decisions. ArcGIS also includes internet capabilities, which we refer to as ArcGIS Online. ArcGIS Online can be accessed through the browser on an internet-connected computer, or since smartphones and tablets can connect to the internet, we access ArcGIS Online in the field. the slide that you're seeing here, on the left-hand side, we see asset information on a smart device. We can see a screen with a map. And if I pick, in this particular case, a hydrant, I can see the characteristics, the asset information about that hydrant, also available to me through my smart device. Now on the right-hand side of the screen, we see a web browser. On the web browser, we see a similar map. We have some additional capabilities because we're in the office, we're on a browser, and we're able to use and interact with this information perhaps differently than we may want to access it on a smart device. For example, city manager might want to use a web map on his or her computer to see a map of their water and wastewater infrastructure to engage the public. For example, using an interactive map in a council meeting to discuss capital improvement projects. By contrast, a field worker would use a mobile app called Collector, which is what we're seeing here, on his or her iPhone or Android device to map the physical location of assets and enter detailed characteristics. ArcGIS for Collector is that mobile app that I'm referring to. It's a mobile data collection app that makes it possible to access your asset information anywhere, anytime, from any device. Simply put, field workers use web maps on their mobile devices to view, capture, and edit data. In this example, moving from left to right, we're first prompted to choose a web map that contains the information that we want to work with. We can see a water distribution system map, we can see a stormwater system map, and we can see a wastewater system map. We simply open the map, and based on the phone's location, the maps open and display the various layers. In this case, pipes, service laterals, hydrants, and valves. We can toggle between base maps, show streets, imagery, topography, and so on. So we know our current location, which is picked up from the GPS chip on that smartphone, in conjunction with the map that contains our asset information. Third from left, we see the detailed information for the specific hydrant. Obviously, this hydrant has already been collected, but if we wanted to update an attribute, we'd simply click the pencil icon in the lower left-hand corner to edit this information. We can also see that we can take and add photos or videos using the onboard camera. Having one or more photos can be helpful. A simple example might be the ability to see one or more photos of the asset before going into the field to perform work on that asset. Or seeing multiple photos of an asset that we're taking from year to year, for example, maintenance or repair records. Let's now take a look at Collector for asset inventory. Okay, let's get started with a brief demo of ArcGIS Collector for asset inventory. Collector is part of the Esri Geospatial Cloud, and it's that mobile data collection app that we've been talking about that makes it easy to capture accurate data and return it back to the office. Field workers use web maps on mobile devices to capture and also to edit data. Collector even works when you're disconnected from the internet and integrates seamlessly back into the GIS database when connected. Here you'll see that I'm doing a screen mirror of my Android phone. In this case, you can see that I've got Collector installed. Collector is available at no cost from the Google Play Store as well as the Apple App Store. Once downloaded, so long as I have a valid username and password or subscription to ArcGIS Online, I can go ahead and launch Collector by clicking on the app launcher. Now in this case, I've already logged in, so it's going to take me directly to the map that I was last working with. And the next thing it's going to ask me if I want to enable my location services. In this case, I'm going to say no because I'm not in Enterprise right now, so I'm just going to use my fingers to pinch and zoom the map, but you'll see the map as if I was in Enterprise, and we can see the Enterprise water distribution system. Okay, so as I pinch and zoom the map, we can see that we can zoom in to a relatively large scale. We've got aerial imagery, if I click the legend or the three dot icon in the upper right and take a look at the legend, we can see what these different symbols refer to. So we've got some field notes, control valves, fittings, hydrants, hydrant valves, service connections or meters, system valves, lateral lines, and of course our mains or our pipes. So that's just a quick way to orient yourself to what we're actually looking at on the map. So I'll close the legend here. And now we can see, as I zoom in, we can see the pipes. They are labeled by both the diameter as well as the material that were input for that particular segment of pipe. We can see a hydrant labeled H3-65, and we can see a couple valves just to the west of the hydrant, and even a couple of fittings where you see the bends in the pipes. So let's take a look at this hydrant H3-65 using collector. So I'm going to go ahead and touch my screen. Where I touched, we do what's called the drill down, so we know we have different layers that are part of the GIS database and part of this map. So it found a couple of tack slots, it found a main, a lateral line, a hydrant, and two valves in the area that I touched on screen. I'll go ahead and select the hydrant because that's the asset that I'm particularly interested in. And if I scroll this form, we can start to see who collected the information, when it was collected. We can see a facility identifier, we can see the manufacturer, we can see the status of the hydrant, whether it's operable, who owns it. We can even see the flow rate, the main size, the T size, the branch size, depth of bury, barrel size, number of ports, nozzle diameter, so on and so forth. So when we think about asset information and we think about where are my assets, we already have the location accounted for. This was collected via GPS by Enterprise. And we can see answers to many of the questions that we want answers to when it comes to asset management. So what do we own? And what are the characteristics of those assets that we own? So this is a simple example of a hydrant that's already been put into the system. And if we scroll down, let's see if I have any photos of this hydrant. I do, in fact, have a hydrant photo. I'll go ahead and open up that photo and take a look at it. So here's a picture of the hydrant that we're interacting with through the map. So that's really how we can interact with the information. And again, if I had my location enabled, you can see how this might be useful in the field to orient yourself to an asset or get close to an asset, and also to retrieve the details about that asset, perhaps while you're in the field or in the office before going out into the field. Now, in another case, let's talk about the act of physically inventorying our system. So I'm going to go ahead and just act as if we're missing a hydrant that we need to add to the database, and I'll demonstrate how Collector can help us do that and capture this information. So in the lower right-hand corner, we see a blue circle with a plus. I'll go ahead and press that particular icon, and I'm prompted with a list of layers in my GIS database that I may want to collect and populate. So here I would say, let's go ahead and collect a hydrant. Okay, I'm going to move the map and just put the hydrant in a obvious location so I can remove it later. I'm going to say update point, and in this case it's going to move the point to where I just panned the map to the crosshair. We can see the form, the same form that we just saw a minute ago, is now empty. So we have the benefit of being able to standardize field data collection, and when we drop into these various forms, we just simply use the keyboard to populate them. So I'll just tag this as demo. I'll put an installation date in. I have the nice calendar control of my Android phone. I'll say today. I can specify the manufacturer. I'll go ahead and say Watrous. I'll just continue down. We'll say that it's active and it's operable. Okay. That's all for now. So I'll go ahead and just check the box in the upper right, or the icon in the upper right hand corner, the check mark. I'll go ahead and submit that feature to the cloud, and instantaneously you'll see that hydrant now appears as part of the GIS database with the attribute information that we entered below. If I were back in the office at this point and I were to refresh the map or zoom the map, or I was another field operator using Collector, he or she would also see that hydrant being added to the GIS database and now as part of the map. Wanted to delete that hydrant, I just click the three-dot icon. I chose delete. I get a confirmation dialog. Do I want to delete the selected feature? And I go ahead and say, yes, I want to go ahead and delete that feature. So that's a simple example showing how easy it is to view the information for an existing asset. We simply click on screen, returns a list of assets or features that were in the tolerance of where I clicked, and I'm able to obviously look at, view the information that's associated with the hydrant. I also demonstrated how easy it is to add a new feature using the add feature capability. Now, one word about data accuracy. So here we saw an example where I used the pinch zoom function of the phone to add a hydrant, but Collector in a typical situation would be using the device's location service to identify your position on the map. In some cases, people want higher accuracy than your smartphone is able to achieve. So a typical GPS chip on a smartphone might give you 1 to 3 meter accuracy in a best case scenario, more realistically 3 to 5 meter. However, Collector does have the ability to integrate with centimeter accuracy, professional grade, or otherwise known as high accuracy GPS receivers. There are several products available from EOS Positioning as well as Trimble that can be tethered to a smartphone, in which case we can get centimeter accuracy, X, Y, and Z, along with the added benefit of using Collector for data collection. So it really puts field operators in a position to collect very accurate information using a smart device or smartphone, something that wasn't possible a few years back. Okay, now what I'd like to do is shift gears for a minute. We've just demoed ArcGIS Collector for asset inventory. What I'd like to do now is shift to using ArcGIS Collector for field operations. What does that mean? Well, while asset inventory is a big piece of the work that we're responsible for, we also know that record keeping is a big part of our job in water and wastewater. So when we think back to inspection reports, we think back to flow testing, we think back to manhole inspections, etc. Collector can easily be extended to support these functions. It really does digitally transform operations. It eliminates these outdated paper-based workflows that we've talked about earlier, streamlines and standardizes data collection. So regardless of who's collecting the information, they're forced to collect it in a similar way, much like you would in a paper-based method. But you have the added benefit of it being accessible by multiple users at the same time. Again, this makes information widely available for field or office use. So if we're talking about flow testing, for example, and I want to, I'm in the field and I want to use Collector to find out the most recent flow test, when it was done, and what that results of the flow test were, I can use Collector for that. But I can also pull that information out to a spreadsheet using the web map. So I want to take a moment here to pivot from just the notion of an inventory, meaning collecting the assets and the descriptive information about an asset, to the type of information that we might collect for purposes of record keeping. Okay, I'm going to bring my screen mirror back into the window. And in this case, I've still got the City of Enterprise's water distribution system map pulled up in front of me. Now in this case, what I want to do is I'm going to move in and look at a another hydrant. I want to interrogate that hydrant to see if there's been any flow tests done on it. And once again, I'll see that I get the pick list where I selected on the map. I'm going to specify this hydrant H3-27. Now in this case, I'm going to continue scrolling down where I can see some operational data. These are called related tables, and basically it allows us to store repair information, in this particular case for a hydrant, a test record, or an inspection record. So let's say that I wanted to collect an inspection record. In this case, I would simply come down, find that inspection table, and I can see that there have been 2 prior inspections performed on this hydrant. So let's go ahead and pick one of those and see what information is in the system. We can see that Sean Young on September 6th of 2017 came out and inspected this hydrant, and he populated quite a bit of information for it. He's got nozzle condition, steam report condition, thread condition. You can see the list here, but we've got quite a few fields that the city wanted to capture for this particular hydrant. So we have those records stored in the database, and if I wanted to go back and look at the other record here, I think I just went into the same record. Okay, then in 2019, we have a different inspector, Andrew, and we have some other information about that particular hydrant, but a year of time has passed. So that's looking at the historical information. How easy is it to add a new record? Well, you can see the add button right in front of you here. So if we wanted to perform a new inspection on this hydrant, I would choose add, and we can see that the form once again is presented to us, and we can go through that form, and we have the same functionality that we saw when we were initially collecting the hydrant information. In this case, the values are a bit different. Have 2 values, either acceptable or repair needed. That information becomes important because when we export this information out to Excel, these are the values that are going to display in that output. Okay, so I'm going to go ahead and close collection, discard, and now I want to pivot to the web map where we talk about connecting the office and the field. So here we've been predominantly focused on field data collection. Question being, well, how can I interact with this information outside of Collector beyond just collecting the information? So I'll go ahead and move this out of the way, and I will bring in the login to ArcGIS Online for the City of Enterprise. I'll toggle this over to Enterprise. I'll log in with the same credentials. And in this case, I'm leaving Collector, and now I'm acting as if I'm back in the office and I want to interact with the map through the web browser. So I'll go ahead and expand this to full screen, and I'll show you what City of Enterprise sees when they first log in. And they're prompted with 3 web-based apps that basically mimic what we saw early on Collector. I'll go ahead and open up or launch the water distribution system. And this web map is going to make the same callback to the cloud, to ArcGIS Online, that Collector made. So in just a moment here, we'll see the water distribution system populate on screen. And we'll see a few other what we call widgets that are available to us through the web app. So we have a little bit more functionality, a little more capability through a web app. We have higher throughput, better bandwidth. So we can do more through a web app, but we certainly can't collect information through a web app because we're not using the web app in the field. So here again, I have a legend to remind us what we're looking at on screen. And I can even toggle layers on or off. And you can do this in Collector as well. So if we wanted to turn off field notes, wanted to turn off those tax lots, and just see the system in general, now we can just start zooming in using our mouse. And we can take ourselves back to the same area that we were at just a few minutes ago. Map's just populating, so it takes a little bit of time on the front end when it first populates. Okay, so I'll zoom in a little bit more here. So now we can see a nice clean map, much larger obviously than we can see through collector. So we can see our valves, and there's that hydrant H365. So I'll go ahead and just pick on that hydrant. Here we see the same attribute information that we saw in collector. We even see that same photo. It'll just open up in a new tab. Close that photo if we want. And I can see the hydrant test, repair, and inspection tables. So we may want to see if an inspection has been performed on this hydrant, just like we saw earlier on collector. And sure enough, I can go in and now I can see all the information that was collected for this particular hydrant. Now, when we come to reporting, we have the added benefit of being able to look at that information as an aggregate. So all of the inspection data in a single table. So I'll find that hydrant inspection table. I will say view an attribute table. You'll see that hydrant inspection table will show up here. And here is all of our inspection data. So we can see who the inspector was, we can see the inspection date, and then of course all of the attributes that were populated by the field staff. We even have that asset management field, or that field that's tailored to asset management, likelihood of failure. So we have most hydrants being at low or very low. But we do have that information, and it is important if we want to ask ourselves, where are those hydrants that are not in need of replacement, or likelihood of failure is very low. We can easily take this information and export it out to a CSV file, get it into a format that many people are more accustomed to working with. So I'll go ahead and export that out to the hydrant inspection.csv. I'll say open, and in just a moment here, I'll bring it on screen. In Microsoft Excel, we're going to see the data that was collected vis-a-vis collector, but in a Microsoft Excel format. So I just resize a few of these fields, and we can see all the information that we would typically have manually entered into an Excel spreadsheet, or perhaps we had to take an inspection report and key it into Excel, time consuming. So we're talking about efficiencies here, where we use collector to input or collect the inspection data, and then we come into the web app to mine that data out of the GIS database into Microsoft Excel, at which point we can sort, filter, do anything else that we would typically do within an Excel spreadsheet. So let's continue on. We've looked at the data itself and demonstrated how collector can collect information and how the GIS can export that information into a usable format, Microsoft Excel. I'll go ahead and close this table and bring us back into the web map. I'll go ahead and minimize this attribute widget, which is where we look at the tabular data. And now I'm back to looking at my system map. Now, a couple of things that make GIS quite unique is obviously the ability to visualize information. So here we have the layers that we're interested in, we want to see, but what if we wanted to see our water system side by side with our wastewater system? Well, here in the web app, I've got the Add Data widget in the upper right-hand corner, so I'll go ahead and click that. And what I'm going to do is add the wastewater system into this map. And this is just temporary, but you'll see the power of GIS here, because in just a moment, you'll see the wastewater system map displayed side by side with the water system. So we can see how this can be very helpful in evaluating or understanding the location of our assets, the relationship of our assets to one another. And again, here we have now a legend. If we open it up, we're going to see that we have manholes, we've got our cleanouts, we've got our service connections, service laterals, quite a bit of information in here. We can even interact with the data from the wastewater system in here as well. So here we have a manhole where we've got the location description, manhole type being a standard manhole, concrete, non-reinforced, not lined. Now, I can edit information directly through a web app as well, much like I do in Collector. So I don't have editing capabilities set up right now, but a person can easily edit this information through a web map or through the web app just as they would through Collector. So you'd have to ask yourself some different examples where this would be helpful to see, but the notion of taking paper maps in the field, CAD maps that may not be readily accessible to you, being able to interrogate detailed information about an asset, which would entail going into as-builts or detail sheets. We can aggregate that information, and that's what we referred to earlier as a benefit of GIS, is being able to aggregate information from the GIS database or into the GIS database to store a wide variety of information. Okay, we just saw a good example of how GIS can help us organize and aggregate information. So in review, we looked at ArcGIS Collector for asset inventory, where I demonstrated the use of Collector to collect the physical location of an asset and also to populate the physical characteristics or attributes of that asset. In the second example, we demonstrated ArcGIS Collector for field operations, where we collected a hydrant inspection record, and we're also able to interrogate the history of the inspections for a particular hydrant. We also looked at how we can use that information back in the office. We can visualize it on a map, easily retrieve the information, but more importantly, export that information out to a common format, Microsoft Excel, where we can generate reports, whatever else we may need to do, but how we can move that data from a GIS environment back out onto the desktop to make that information actionable. Now what I want to do is provide another example using ArcGIS Collector for field operations using a wastewater system as an example, where we're going to use the inspection data to actually visualize the data on the map. Why would we do that? Well, it's one thing to collect data and to move it into a centralized repository, and it's certainly helpful to be able to export that information out to Excel. But if we think about a map-centric approach to managing our assets, we actually have the ability to use that information to visualize where work needs to be done using Collector as well. I'm going to move my Collector screen back into view. And I'm going to open up Collector, and in this case, we're going to open the wastewater system, but specifically a task-focused app that's largely focused on manhole inspections. So in this application, we can create a new inspection, just like we'd done earlier. And what we see in front of us now is the wastewater system. I'll go ahead and open up the legend. And we can see that we have cleanouts, and we can see we have manholes mapped. And of course, we have our gravity mains. What I can also do is associate those inspection records back to the manholes, and we can symbolize data based on values that you, the field operator, are putting into the database, so you can actually see that information come full cycle, help identify where work needs to be performed. Let's first take a look at where we completed inspections on manholes. I'm going to go ahead and turn on this layer called Manholes Inspected. And what we can see right out of the gate is we've got orange symbols that represent where inspections occurred. So I can see a couple of manholes that may not have been inspected for one reason or another. Perhaps they were collected after the fact and the inspection did not occur. This would be data that was collected in 2019. So that would certainly raise some concerns, but now we're visualizing the data and we're identifying where inspection records were not completed for one reason or another. Second thing we may want to do is actually look at the inspection data. And what I've done is I've focused specifically on the channels and the condition of the channels, the flow of the channels. Let's take a look at the legend in this case. And here you'll see we took a single field or attribute within the inspection report, and we symbolized the data based on the inspection report. So we can see we had 4 allowable values for manholes inspected and the channels attribute. We had the notion of restricted flow, slow flow, normal flow, and a value called other, which upon further interrogation indicates that there was no value entered for that particular manhole. So perhaps that flow or those channels were not visible during the inspection. That may be a concern, something they want to go back and complete the inspection at a later time. Could be any number of reasons why those values were not populated. But what we do see is, if I close this legend, we can now see specifically which manholes could be problematic in terms of flow. So if I'm now in the field and I've got my GPS enabled, we can actually zoom in and we would be in a view something like this. We'd see our location displayed, and we would have the ability to actually identify which manhole perhaps needs to be cleaned and maintained. So in this way, we've got, again, the inspection report that tells us specifically where or what the characteristics of each inspection were. But this map is a task-focused map, which is tailored to helping field operators identify specifically which manholes need to be maintained. Okay, let's look at another example, still using the manhole inspection data, but let's look at that information back in the office through a web application and look at some different ways that we can work with that information in the office. Perhaps it's just to produce a simple map that we want to hand over to our field crews who may not be using Collector. I'll go back into the City of Enterprise's ArcGIS Online account. And in this case, I'll go ahead and open up the wastewater system web application. And we'll see the water distribution system will load. Okay. So here again, we see a similar map to what we just were looking at in Collector. But in this case, I want to look at the manhole inspection data. So we're going to go ahead and find that manhole inspection table. We're going to view the records as part of an attribute table. So here we see that same information. Here's that field we were looking at earlier that was symbolized in Collector, showing the various flow in the channels. So what we'll do here is I'm going to apply a filter, and I'm going to do what's called a query. It means I'm going to build an expression where a certain condition is met. I'm going to find that channels field, and I want to find where the flow is not normal. So I build the string, I say OK, and now I have 39 records where my channel value is either restricted, slow, or other. I've eliminated normal flow. So because this table is related back to our manholes, I am actually going to say, show me the manholes that match these 39 records. And there I have 39 manholes. So we're no longer looking at the manhole inspection data. We're actually looking at the manhole asset. And I'll scroll down and just select all 39 of these records. I'll go ahead and close the attribute widget because I have applied my expression. And now I can see those manholes highlighted in blue that meet my criteria. Well, perhaps all we want to do here is produce a simple map. So I'm going to zoom into an area where I see some problems. And I'm going to go ahead and change the base map. I think there's a base map that might be a little bit more helpful for my field crew. So I'll come on down and I'll find what's called OpenStreetMap. And in just a moment, you'll see the base map will change from the aerial imagery to what's called OpenStreetMap, which includes road names, de-emphasizes the importance of aerial imagery, provides some additional context to this map. And now I've got a map showing the locations of those manholes. So let's go ahead and just output that map to a PDF. So I'm going to just give it a manhole inspections flow issue. I have some options on my layout. I'm going to choose letter ANSI a landscape, which is 8.5 by 11 landscape. I'm just going to accept the defaults of PDF, and I'm going to say I want to preserve my map extent, which simply means I want to see everything that's visible to me on my screen. I'm going to go ahead and choose print. We're going out to ArcGIS Online to the cloud, generate a PDF map, and in just a moment, once that print is created, I'll have a PDF that I can open and then easily print or email to somebody if they wanted to have that map on their person. Okay, so here's my map. The print has been created. I'll go ahead and open that map. And we can see how easy it is through ArcGIS Online to generate a professional looking map. So in this case, I've got a legend in the lower left-hand corner. I've got the date created. I've got the custom title. I've got a scale bar. So I can easily print that map, or I could download that map and save it. I could email it to a colleague. So here again, we find a way that GIS makes us more efficient and connects the field with the office and allows us to revert back to some of those more practical workflows where if we didn't want to use Collector and take a map with us, or we didn't have the capability of Collector as a field worker, maps are still in play, and we can certainly produce a map that contains much the same information that was available through Collector just moments ago. I hope that I've given you a few examples today of how the ArcGIS platform can be used across the organization to make it easier for everyone to discover, use, and share maps. Looked at the concept of map-centric data collection, transforming from paper-based methods to a centralized GIS database. And in Collector, using GIS for asset inventory, mapping the physical location of an asset, adding the characteristics of the asset as attributes through the forms. We looked at field mobility, having maps with you on your device, anywhere, anytime, being able to look at historical information and also collect new information or inspection reports. We also looked at decision support, the concept of using GIS in the form of a map on a field-connected device to prioritize work, identify where work needs to be performed, as well as looking at that information in the office through a browser and exporting it to a common format that can be used for reporting. When aligned with the business needs and priorities of the organization, in this case asset management, ArcGIS can help eliminate paper-based workflows and start helping us answer questions. What do I own? Where is it? What's its condition? What's its useful life? And what's its value? Preparing an asset inventory and system map is that first step. At Anderson Perry, we understand the challenges that our customers are facing, and we're using the ArcGIS platform as a system of engagement to modernize workflows. By embracing the concepts of location strategy, self-service GIS, we're improving how information flows through the organization and how it can be used to organize, aggregate, collaborate, from any device anywhere at any time. The ability to access your asset information in this way provides each of us with an opportunity to ask ourselves how we can each use GIS. At the start of this presentation, I said that my hope for today was two things. One, that you leave with an understanding that GIS is more than just a map. Two, that you glean one big idea for how GIS could streamline your job in water or wastewater operations. From the city of Hermiston, who's collecting accurate manhole locations and rim elevations, to the city of Baker City, that's using GIS to track valve exercising, to the city of Enterprise, that's using GIS for manhole inspections. I hope that I've demonstrated that GIS is, in fact, more than a map. For my second goal, gleaning that one big idea for how GIS could streamline your job in water or wastewater operations, I hope that I've given you an idea or two that you can talk about with your colleagues and ask yourselves if you're ready to transform asset management for your organization. On behalf of the Eastern Oregon Operators Conference, I want to thank you for attending today's session. And please, don't hesitate to contact me if you have any questions or want to discuss your big idea.